Welcome everybody to our second webinar in the Efficient Electrification Toolkit series. I have with us today Adam Dixon, who's going to run us through some of the tools available. And we also have Michael Oriahi joining us from Save on Energy to give us a brief update on programming. So our agenda for today, we're going to do a welcome and introduction, which we're doing right now. A review of the toolkit, which you may have seen if you joined us in our first webinar. And today we're going to be diving into the interactive fact sheet and life cycle cost analysis tool. And we'll be looking ahead at what's coming up next in the toolkit series. We've also got about 20 minutes reserved for Q&A at the end. This is a hands-on workshop today. And I want to make sure everybody has a copy of the resources that were shared Tuesday via email. If not, let me know in the chat and I'll drop a copy in there. So our objectives for today are to practice using the tools. Adam's going to give us a live demonstration of some of the available tools, and everybody's got a workbook and a copy of the tools so you can practice alongside us. And then we'll go through some next steps. Like I said, we have some mini workshops coming up to use the red screen tools that have been made available. And we have a technical help desk. So you can email us at any time and get support with your own projects, kind of one-on-one. With that, I'm going to introduce Michael Oriahi. He's going to talk to us about Save on Energy.
Thanks a lot, Megan. My name is Michael Oriahi. I'm the business advisor for capability building at the ISO. I'm just going to quickly provide some updates before we go ahead with the topic at hand. Firstly, I'm going to focus on a few program updates. The first being the retrofit program. As of December 18th of last year, all lighting measures, which have previously been in the retrofit program, were moved to the instant discount program, which is a point of sale. It's a point of sale discounts for energy efficiency lighting to customers. And in this case, the benefits is you don't have to worry about paperwork. You don't have to worry about applying for the program. Once you just go and purchase the lights, it's instantly applied to your purchase. Some changes made to the, I'm sorry, there was a change quickly. Some changes made to the retrofit program are we did bring back we reintroduced the custom track in May of last year. Also, many of our incentives doubled, tripled, a few quadrupled, and that include many HVAC measures, including air source heat pumps. Something not on the slide deck, but a quick update on that is our energy performance program. And our service provider, Nerver, currently is launching a EPP portal. And the point of that is for it to be user-friendly, have an automated baseline energy model, and it has various tiered incentive rates for peak and on-peak. And that launched, I think, a week or two ago. And then we have our SEM, the Strategic Energy Management Program, as well as our EBCX programs. We provide, the SEM is a cohort-based incentive program, although it has some pay for performance for unclaimed savings, as well as our EBCX program, which is three-phased with investigation, implementation, and persistence phases, and having various incentives at all three phases. Next slide, please.
Michael, we have a question about the deadline to complete any retrofit program applications. There was a 2-year timeline. Is that still in effect?
Yes, it is.
From the pre-approval date? From the
pre-approval date, yes.
Okay.
Training and support. As we're saying today, we do provide a series of training opportunities, including webinars, workshops, some coaching cohorts, one-on-one coaching, as well as some asynchronous resources like fact sheets, guides on various topics, including electrification, energy data, with the point of it being that we want to provide some support for you across your energy efficiency and electrification journey from, when you're starting, or if you have challenges at various points in it. We do offer 50% incentives for about 18 energy efficiency training courses. And for Enbridge customers, we do offer up to 75% incentives on a set X number of courses. We launched our training and support webpage last year, and the video recording for this webinar and all of our webinars would be on that website, as well as all of our other training resources. Will be found on the website. I believe we might explore how to do that later in this presentation. One last thing, also not on the slide, I just wanted to quickly mention was that on February 9th of this year, the minister sent a letter back to the ISO requesting we explore options on the post-2024 framework and programs. And it spoke to opportunities on a more enduring framework, expanded program offerings, as well as objectives and targets for beneficial electrification. While this is not necessarily a directive from the government, it does give a bit of sense on where we might be headed in the post-2024 framework. Thank you, Megan. Over to you.
Thank you, Michael. I'm going to introduce Adam Dixon at this time. He's going to run us through the next steps.
Good morning, everybody. I recognize a few names in the workshop here, so welcome anybody who's received training from us in the past. So myself and my father, who we have a small company called No Energy here, we have been working with CIET and the ISO to develop kind of this the toolkit and what I'm about to show you on when I share my screen, which is our 5-step approach to and where you can use these tools in order to achieve efficient electrification in your buildings or within your organization. And now, if you've done any research into efficient electrification or electrifying things in your building, you've probably come across a similar process. We've kind of done a lot of research around this. There's some 3-step approaches, and if you've attended any of our courses in the past, we usually stick to a pretty simple methodology in terms of energy efficiency, which is reduce waste, maximize efficiency, and then optimize supply. This process here is basically breaking that down into a few more steps to kind of give you a bit more information along the way. There's a few other groups out there that have put out similar processes that are around 7 steps, but again, the end goal is usually the same, and they may just word it a bit differently from what we've outlined here. So the first step we're going to go through here. So again, I think number one, you kind of have to do every time. I think this kind of sets what are the next steps you need to just consider, or you can skip over and move to the next step depending on what your organization's goals and constraints are. So understanding each building's constraints and establishing intelligent, realistic objectives are key to this project success. So things like capital costs, how much budget do you have to do these kind of things? This can get into, we're not going to get into it in this webinar, but this goes into service entrance size in your building. So when you're electrifying your heating sources, which is kind of the goal here, you do need to consider how much capacity you have in your building to do that. You are taking on more electricity demand, so you need to consider things like that. What are your carbon goals in your organization? Is that a goal at all? So considering those things like that, that may influence things like your increased electricity cost may be offset by your carbon reduction cost there. So kind of establishing those things is very important up front. Then maybe you say, okay, I need to move to next step 2, which is to reduce our heating demand. So reduce your heating demand. This basically want to do things to the building to reduce the waste in your buildings. This way, we do not have to buy or purchase as big of an electrical heating system or a hybrid system, which I'll tend to default saying electrical system here, but you'll see in the end, we do explore not just fully electrifying your building, we do get into some of the hybrid systems at the end as well. So reducing your heating demand usually implies that you need to buy a smaller system when you do get into getting into your HVAC systems, which reduces your capital costs up front. The next thing is to optimize that HVAC system. So once you've kind of established which direction you want to go, you want to reduce the waste in the building's mechanical systems through things like temperature control, zoning, and heat recovery. So make sure your current building is kind of as efficient as possible is kind of the goal until this point. Then what we want to do is move to step 4. So this is where we're going to electrify or consider electrifying our heating system. So using some life cycle costing tools and some more detailed tools. We will get into using RedScreen. If you're familiar with RedScreen, it is federal government energy modeling software where you can kind of explore in a lot of detail, if you know how to use it, the full life cycle and risk analysis on electrifying your heating systems. Then the final step, step 5, is balancing your heating and cooling sources. So explore the cost and GHG implications of different fuels, including hybrid and all electric systems. And in this step, you can also get into, if your goal is something like net zero by a certain date, you can use these tools to kind of bring on things like on-site renewables and off-site renewables as well. So it kind of encompasses the whole process to going. Again, the goal by the end, in theory, not every organization is going to achieve this, is to get to net zero. If you follow this process, you will be on the pathway to achieving net zero in your building, which I think for some organizations is the goal. But again, it will drastically reduce your greenhouse gases as well as your energy intensity in your building if you follow this process. So let me just move to the next slide here once I figure it out. So what is in the toolkit? So there's lots of different tools that are available and will be available to you. I'll just quickly show you where it is if you have not come across the way actual toolkits are available. It is up on the Save on Energy website. There is the 5-step process, as well as some of the tools that are currently available to you to follow this process. It is an ever expanding toolkit, so I would recommend checking back in. It's not what is here today will not necessarily be there next week, so I would make sure you check it. And I can actually, if someone can post that link in the chat, that's where you can access a lot of these tools here. So our goal with these toolkits is to set up kind of 3 segments of tools. So there's the technical planning tools, so some fuel switching calculators, life cycle costing tools, RedScreen templates. Those are kind of some of the tools we're going to explore in this webinar. There is training opportunities, which I guess this one kind of follows under there as well. So we have some net zero planning with RedScreen, financial analysis, electrifying HVAC and heat pumps. There is going to be a lot more detailed calculations with actually modeling your HVAC systems, some training coming online for that stuff as well. So we're starting out kind of simple. We're going to build into the more complex, more technical details in planning this whole process. Then, and hands-on support. So we want this training and support and toolkit to be as hands-on as possible. We want to give you the tools to make these decisions. The tool is not going to make the decision for you. You have to apply your situation to these tools and then make the best decision based on what it spits out to you. And the answer may not always be what you think off the top of your head. That's kind of what these tools are designed to do. So accessing these tools, so we have, we posted that link there and the training and support. I would recommend going out there, check out all the tools that are available to you, as well as the training that the ISO offers. There's going to be more and more coming out in the next year or so. So now, right now we're going to jump into, point you to some informational resources available. So I'm not going to spend too much time on these ones. They're available to you online. I think they're relatively straightforward in explaining some of the higher level things about efficient electrification. They are available on that link. There's some PDFs you can download. There's some nice infographics there as well. But the main goal of this webinar is to dive into some of the tools that we have up there, some Excel calculators, basically an interactive fact sheet, which is a kind of a higher level look at efficient electrification. Then we're going to dive into a simple life cycle costing tool. But when we say simple, it doesn't mean it's not effective. I think it's actually, in terms of some of the more detailed life cycle costing tools I've come across out there, it's easy to understand. If you're not a financial person, you need to enter some very simple numbers here, and you can spit out very quickly whether a project is worth doing for your organization based on those parameters. So here, again, we developed this tool a couple years ago now. It's been available on the Save on Energy website for a while. I think it's a good starting point for your journey into efficient electrification. So basically, we have some static parameters about a building that are built in. We can then go in and change a few things, so we can explore what our current fuel is in our building, what we want to switch to. We can pick a general location. Again, doesn't cover off everywhere in the province, but we did try to cover off kind of a broad climatic zones there. You can pick some of your insulation levels, and then some energy efficiency measures you do in conjunction or prior to actually switching to an air source or a hybrid heat pump system there. So, and then it spits out some annual operating costs, carbon emissions impact, savings to investment ratio, internal rate of return, net present value, and simple paybacks there. So if you're not a financial person, don't worry too much. You don't need to be to kind of understand what these numbers are telling you. There's some general rules of thumbs you can use to say, okay, well, if my net present value is negative $10,000, should I do this project? The simple answer there is no. A negative net present value is probably not going to fly within your organization, depending on what your overall goals are there. So for right now, what I'm going to do, actually first, no, I skipped over some stuff. We're going to go into that worksheet that was supplied to you. So there is using the Toolkit Microsoft Word document here. So we've covered off the first couple pages here. So we have our steps. We have established goals, reduce demand, optimize, electrify, and then balance the heat sources. So the first thing we've kind of given you here, kind of rewind prior to that interactive fact sheet, is we have given you a little bit of a tool to kind of brainstorm ideas or things that you have done in your building based on these steps and unknown variables, or maybe things you need to consider in the future for your building. So we have step 1, identify goals and constraints. So we have an example here, commitment to achieve net zero emissions by 2050. And an unknown variable, an example of that would be we need to establish an operational emissions baseline. Right now, we don't really have any information on what our emissions are in our building. So we're not going to actually go into this and get you to fill this out right now, but you can use this tool to kind of brainstorm ideas or things through your journey through electrification. Now, before I do move on, I will say, is there anybody here who's willing to speak up? You can feel free to turn on your mic, who has done something in their building already to try to efficiently electrify, or in terms of unknown variables, some of the obstacles they're maybe running into or things they need to address in their building. Feel free to just open your mic, raise your hand, speak up, and we can see if anybody has any interesting scenarios they've come across in their buildings. Nope. Or even your house. I say this process, we target this to commercial, institutional, industrial organizations, but this process does work in your home as well. I know a lot of people, given the amount of incentives that are available to electrify your heating systems in your house, have kind of gone through this process, or hopefully gone through somewhat of this process. And then if you are doing that, I would also recommend using this process in order to do that. And also it gives you questions to ask contractors and people that are coming into your house to do these things. I know there's a lot of misinformation out there about switching to heat pumps in your homes, but this will give you the tools to be able to, I think, ask those questions in that scenario. I know with myself personally, I'm in the process of switching to a heat pump in my house. So I've used this process. I'm insulating my house. I'm doing all those sorts of things before I go out and actually buy a heat pump. So I don't have to buy an oversized heat pump that's going to be inefficient. Okay, so now what we're going to do is we're going to move on to this case study. So we're going to take some of this information, we're going to see how we can apply it to that interactive fact sheet, so we can see how that's somewhat of a high level, and we can maybe see where its capacity stops. So maybe some things we can't do with it, which is also what you need to know. You need to know what your tool is good for and what it doesn't do. You can't just use one tool to do everything. It's kind of like, I like to use the analogy of a chef's knife. You need to know what knife to use in what scenario. You don't use a butcher's cleaver to do everything. You have anywhere from a paring knife to a chef knife in order to do what your goals are. So this, I would say, this interactive fact sheet on that analogy is more of the butcher's cleaver. It gives you to kind of chop things into big segments, kind of narrows down where you need to look in your buildings or organizations. So here we have Modern Tech. It's a 2,500 square foot meter educational facility located in Kingston, Ontario. An on-site energy manager wants to explore the energy emissions reductions potential and cost implications of replacing 8 existing gas-fired rooftop units with air source heat pumps to support the organization's commitment to emissions reductions. Currently, the RTUs contribute 80% of natural gas. The RTUs account for 80% of the natural gas in the building. The remainder is to service domestic hot water. As an energy manager, she wants to complete the project as efficiently as possible and wants to include some energy efficiency projects in the analysis, including air sealing, whole building, demand control, ventilation, and heat recovery. So these are kind of the maximize the efficiency of your building, which would be under step or reduce the heating demand also, but step 2 and 3 here are doing these energy efficiency measures here. So she has identified the current insulation levels in the building as medium. So you can see that's kind of a very high level. We're not getting into actual R values of the walls at this point yet. So the existing RTUs have an efficiency of 85%. I would say that's the seasonal efficiency. If you're ever getting into these kind of calculations, you want to make sure any efficiencies you use are the seasonal efficiencies, not necessarily the nameplate efficiency you get on your devices. So just be careful when you're looking into that. She uses the following estimates for the air source heat pump. So they have a cooling COP of 5 or 500%, and they have a heating coefficient of performance of 2.3 or 230%. So depending on what the inputs are, sometimes you need to use a 230% efficiency instead of the 3 when entering things in certain calculators. So we're going to use that interactive fact sheet, which I'm going to pull up here in a second and kind of show you what's on here. And we're going to go through and say, fill out this table here. And then once we're done that, I would say we can make a decision on whether we could do this, or what I would say is we go through the life cycle costing tool, so a little bit more detailed costing tool, and see how those numbers compare. So it doesn't give us the same result. So I'm going to pull up that efficient electrification interactive fact sheet, and again, that should be available in the chat, or it is also available on that website link to download as well. So here, what we're going to do is there's a few static parameters that are built in here. So we can see a floor area, which maybe already is a bit different than what our example is right now. So we can see maybe that's a limitation of this project, but maybe the general, I would say, shape of the curve on this, or so generally it's scaled up and down based on the size. So whether it's a 2,500 square foot or 50,000 square foot, the percent reductions and things like that will be the same. So we can see if the financial metrics are positive or negative. That's kind of all I'm going to say at this point. So we have an RTU efficiency of 85%. That is already set in that. That's what we have in our worksheet, so that's good. We have new equipment cooling is going to be 5, a coefficient of 5, and our new seasonal efficiency for heating is going to be 230%. Just generally, we see heating efficiencies in percentages. That's why we put 230%. So now we can sort of play with these adjustable parameters based on our current fuel, our new equipment, our location, our insulation level, and any energy efficiency measures that we have currently done in the building. And now on those energy efficiency measures, we've limited it to 3 or combining 3. These are essentially just percentage reductions in your energy usage. So if you've done other things to reduce the consumption in your building, you can look below. And so air sealing generally can reduce your building's heating energy by 10 to 20%. Heat recovery, demand control as well. You can use those percentages to kind of simulate other reductions that have happened in your building. So sometimes if you understand what's going on, these are just labels and you can use a bit of a workaround to get a simple answer for yourself. So in this case, we do have our existing building is natural gas. You also have the option of propane, which is relatively common as well in the more rural areas. We want our new system. So we have an air source heat pump, or we have a hybrid system. So a hybrid system is where you're going to have a relatively smaller heat pump where you use your existing gas furnace to kind of on the super hot, cold days in the winter there. So it's kind of a peak load heating system there. So we want to use our air source. We're not actually, maybe I should follow the worksheet a little better before I move on. So we're just going to do the air source heat pump. I'm going to move this to the side so I can record some data as I go on. So the first thing we're looking for is we're going to look for with the metric is with no energy efficiency measures. So we're going to go through, we're going to pick natural gas, air source heat pump. We want to change our location. So we're going to look at Kingston. So we have Ottawa, Thunder Bay, Kingston, and Toronto. So it doesn't cover off the entire province, but for the most part, you can probably get a good estimate in your area. Unless you're in maybe the far, far north of Ontario. Even then, Thunder Bay is probably a good proxy for that. So our building insulation condition, the energy manager has identified that one as a medium. And right now we're going to look at the cost and greenhouse gas implications for no measure. So we're just jumping in here and we're just going to put heat pumps in. So we use ret screen in the background of this to calculate these numbers. So we used basically standard ret screen costs for electricity, gas, as well as the cost of the equipment to spit these numbers in. If you're interested in kind of what's going on behind the scenes, I would recommend reaching out to the what's it called? The hotline here. We have the helpline. We will post a link to that at the end of the course, so you can email the ISO and we will direct you to someone who can answer your questions. If you're curious what's going on, we can help you a little bit more detail there. So we can see now the project outcomes based on this, and that's kind of somewhat of a limitation to this. The cost of electricity and the cost of gas are kind of set based on when we built this tool. So as you can see, maybe as the costs change on certain utilities, that can drastically affect how these projects work out for you. As right now, the cost of gas is typically going up, so that would be maybe make this project look a little better, switching from gas to electricity in this case. So we have an annual operating cost savings of $3,150, so we save that annually. We have reduced our carbon emissions by 93%. Our savings to investment ratio is 0.21. And if you're unfamiliar with a savings to investment ratio, a savings to investment ratio of 1, that's kind of the break-even point. That's where what you invest, you save what you invest. You're not making money, you're not losing money. So you ideally want to see this number above 1. The more above 1, kind of the better this project is. The internal rate of return on this, again, this is a negative number, so negative 9%. This is essentially the rate at which this project is returning money to you. If you're interested in all of the details of these financial metrics, you can reach out to that help desk, or also just Google these numbers. There's lots of documentation about that. We just don't have the time in this webinar to go over all of those. So our net present value. So basically, the rule of thumb on this one, if the net present value is above 0, it's a viable project. Again, the more above 0, the more. This is the net present value is the value of future cash now to you. So this is right now you're losing almost $110,000 over the, I forget the lifespan or the timeline we looked at this on, but we're losing about $110,000 on this one. So right now this doesn't look very good. The simple payback on this is 44 years. Again, very long. This heat pump probably not going to last 44 years. So as of right now, in Kingston, Ontario, with the prices we've used in here, just jumping in there and switching 15-year, it's a 15-year timeline on this one. So yeah, we're losing, you don't want your simple payback for sure to be outside of your timeline there. And we are saving $442 ton per ton of carbon avoided. So that number is good, but the rest of these financial metrics, to me, this project is not viable. Although you do reduce your greenhouse gases by 93%. So if you're not hindered by capital costs and you don't need to worry about these things, if your goal is simply to reduce carbon, yeah, maybe you jump in here and do this. And this is where I find this tool is useful. You can see the value of doing those energy efficiency measures first before jumping in and doing your heat pump here. So what I'm going to do is quickly record some of these numbers. So we have our operating costs, 3150. Our carbon emissions impact is negative 93. Investment ratio is 0.21. Internal rate of return is negative 9. Okay, 4.2. So now what we're going to do is we're now just going to add in a measure to see what happens to these numbers. So we can see here, we want to add in demand control ventilation. So this is when your ventilation only comes on based on whatever metric you set when you need it, essentially. So we can see here now, well, that's going to reduce our heating load. We can see by the little table below by up to 40%, depending on your building. So now we can see here, now our savings, our annual operating cost savings jumps to $6,500, just over. Our carbon emissions, again, we've now reduced it even further. Our savings to investment ratio still below 1, so we're still technically losing money on this project. But again, if your goal is net zero or something like that, you may need to go ahead with projects that aren't necessarily as viable. So your internal rate of return, now we've switched. This one is positive. So we have a 1%, but still not great. Ideally, you want to see a little bit better return on your investment here. We do, and we still have a negative net present value of $40,000. So essentially over the 15 years, we're losing $40,000 on this project. The simple payback is 18 years. So we are getting a bit better there, but still outside the life of this project. So 15 years. And we have $275 per ton of carbon avoided. So now we can see, we can add in another measure. So now we can add some heat recovery into our building. So now this is where the project starts to really shine. So doing this, we can see doing energy efficiency measures does matter when doing this efficient electrification. So we have our annual operating costs have jumped up to 9,545. Our carbon emissions impact, we're now at negative 97%. Our savings to investment ratio, we're now up over that one. One is kind of the threshold here you want to see. So at the end of this project, essentially, if this was a $100,000 project, at the end of the 15 years, I'm going to give you back $120,000. That's essentially what that is saying. And now we have an internal rate of return, which is positive at 8%, that's a good number. We have a net present value of just over $19,000. And the simple payback is now 10 years, which much better. We're under that 15 years life, and we have $124 per ton of carbon avoided. Now the last one is to add that third measure. So it's demand control, ventilation, air sealing, and heat recovery. This one, we've kind of drastically reduced our heating load in our building. So now we're saving $13,000 a year. We're 99% of our carbon is reduced because we're basically the only thing that would be accounted for here would be the hot water in our building. We have a 2.1 savings to investment ratio. So we're essentially doubling our money at the end of the project. An internal rate of return of 17%, which is very high. That's more what you would get as an interest rate on a credit card rather than a return on investment. So we have a net present value of $86,000, a simple payback of 5.9 years. So again, well under that 15 years now, but we do actually we have a negative carbon savings here, which intuitively, that's not what I thought would happen, but that's what the calculator tells us here. So now we have all these numbers. We can see that, hey, maybe jumping in and what I thought, just installing a heat pump isn't as good of an idea as I thought. We need to do some measures first before we do it. But as you can see, this tool doesn't give us a lot of transparency on what things cost us. So what did that demand control ventilation cost? What did that air sealing cost? Things like that. Are those things that we can do in our building, or are there other things we need to do? So now, unless there's any questions on that tool, what I'm going to do is use some of that same data along with a little bit more detailed data, and we're going to jump into kind of a simple but powerful life cycle costing tool here. So and some of you may have come across this tool in the past. I know it has been put out there before, but you can very quickly, with very little inputs, get, I'd say, a more solid answer than this one on more specifics to your building with this tool. So what I'm going to do, and that tool again is available in that link, and it's also available in the chat here as well. So if you've downloaded that tool, it does come pre-populated with an example of a net zero building, I believe. So that is actually real numbers. We've scaled up. It's a building in Ontario that used this tool to somewhat decide whether to do a net zero building in their scenario. So they spent, and it did, if you look at it, it did actually make sense to spend, I think it's an extra $1 million up front in order to achieve net zero now, rather than maybe waiting a few years when they would have to replace the building anyway. So I'm going to pull up our worksheet here to see what we have, what additional information we have. Here we go. So we have our interactive fact sheet data, so we can maybe see how these numbers compare once we add in a bit more information, a bit more flexibility to customize it. So the results from exploring the scenarios in the interactive fact sheet help Modern Tech's energy manager decide which options to explore further. Now, using historical energy data and real costs obtained using the efficient electrification tool to make the same decision. So here we have some financial parameters that we can actually set rather than using what red screen or what that interactive tool sheet has used. So we can set our inflation rate, so our general inflation rate to 2%, which maybe some people might argue is a little low for right now, but we'll go with it for now. Our energy inflation rate at 4%. Our discount rate, so the discount rate is not the discount you get on buying certain appliances. That is sometimes what people think. This is how you discount future cash back to present cash value. So it's the percent, and we'll do that. Again, not familiar with that, Google discount rate energy, and there's lots of information and documentation out there about that. So here we have some energy data. So we know our electricity cost is 13 cents a kilowatt hour. We have our natural gas cost at 45 cents a kilowatt hour, which is, I'd say, fairly representative of what most people pay in Ontario here. So we have option A. So this sheet allows us to explore the differences between two options. There is a sheet available that does 3. If you want access to compare option A, B, and C, reach out to that help desk and we will send you out an additional sheet that has 3 scenarios in there as well. So the option A is basically to replace a like for like, or do nothing or replace like for like. I think when we get into the example, we are going to replace like for like at a reduced cost compared to the option B. Option B, we're going to install an air source heat pump and demand control ventilation. So we have some consumptions before and we have some estimated consumptions after we do that project there. So, and we know we may have to adjust this consumption here. We are told in the previous example that the RTUs account for 80% of the energy. So we do have to, unless we're switching to an air source heat pump for the hot water, we would have to subtract out, which I'm going to assume in option B is the remaining natural gas per year. So we can subtract 39,000. I'm just going to do that right now, which is 31,206. So our actual consumption is 31,206 meters cubed. That's what, and then our initial project costs here. So we have option A, we have 8 gas-fired RTUs installed at $120,000. There was a question there. Was that regarding the interactive fact sheet, or was that with this tool here? Oh, it's this tool because you changed the discount rate. So hopefully we'll expose that in a bit here. We'll hopefully answer that question after we kind of go through the sheet a little more detail. So we have 8 gas-fired rooftop units that were $120,000 to install. The O&M costs on these are $12,000. I think that's per year. I believe that's per year. Our emissions are 73 tons. So you probably will have to do a bit of digging to get this information. You may be able to use some of the tools in the future that we provide in this toolkit, like Red Screen, to calculate some of these. Or you'll be able to look up on some of your energy bills and find some of that data. So option B is to 8 air source heat pumps with equipment cost of $213,000 or just over. The installation cost on that is $45,000. The demand control, ventilation, sensors and controls are $136,000. The installation costs and programming, additional $75,000, and then 8 by heat recovery add-ons for the RTUs installed at $190,000. So we have a total cost, if we did all of those measures, at $660,000, which is, it looks like a lot more. You're like, how would this project ever fly? You're spending so much more money up front, but that's where this tool can help here. So right now, we don't have any operation and maintenance costs or savings. There might be. You do still have to maintain heat pumps, so just hopefully it will be a less of a cost. And we could even explore, once we get into the tool, even if they were equal costs, because you probably want to have a regular maintenance schedule on any of your HVAC systems in a building of this size. So we can explore even if that changes the finances at all. The emissions we've reduced from 75 tons to 15 tons. The remaining greenhouse gases are from the hot water and what little percentage of that comes from our electricity consumption. So what we're going to do before we fill out this table is we're going to actually dive into the tool and enter some of these numbers. So basically, the user on this tool, you need to input the yellow cells. Some of them you don't have to put in order to calculate, but most of them you do. The main one you don't have to put in is this user selected carbon price. So we kind of have a baked in price of carbon inflating over 30 years. You can use your own numbers in here in the yellow cells if you want in that case. And red screen, or not red screen, Excel will use whichever number. If you put a number in here, if I was to put 75 in here, it will actually default and use the 75 in the calculation. So you do have some flexibility in the pricing there as well. All the other sheets, they should be, in the tool you download, they are locked. So if you're looking at the discount rate formula, we're not using a formula here to calculate it. You're going to have to research the discount rate here. There are formulas, there's a number of them out there to calculate a discount rate. I would talk to somebody in your financial department on what they use for a discount rate. Somebody in finance probably knows that number. I'm not inherently a financial expert, so I'm not going to recommend what each organization is going to use. It is a pretty wide-ranging number depending on where you come from. So there's no calculation there to answer that question, but there is calculations out there to calculate that number if you don't know. So our inflation rate, so this is our other inflation rate, so our general inflation rate is 2. Just make sure I'm entering the right numbers. Have this sheet on the side. There we go. Our energy inflation rate is 4. Our discount rate is 3. So in your sheet, this is probably labeled, I forget what that was labeled, but this is the normal building, and then the labels on them is net zero plan. You can label this whatever you want. I just labeled it like for like. The initial cost on this one is $120,000, which is just replaced with 8 rooftop units. Now we have our electricity consumptions here, so we can put in our usages. So we have in our option A, or base case, we have 102,880 kilowatt hours of electricity. And that comes at a cost of 13 cents a kilowatt hour. Our natural gas consumption is 39,007 meters cubed, and that's at a price of 45 cents kilowatt hour. So you can see as I type numbers in here, these numbers get kind of accumulated over the 30-year span of this project. We do have the ability later, if it's not a 30-year project, we said it's about 15 years actually, so we could reduce that and see how that changes the numbers on as well on the summary of the results. We do have our cost of our O&M costs. So we're told that we spend $12,000. And the period here, so this is, if you put a 1 in here, that's going to happen every year. If you put a 2 in there, it's going to happen every second year, and so on and so on. So if you don't have to have if your regular maintenance schedule is not annually, or you could even go down if it's semi-annually, you could reduce that as well there. Our carbon tax, so on natural gas, so the cost of that, this actually shouldn't be a cost. This should be the number of tons. So it's 73 tons. It's going to use those numbers below there. So now we have our kind of initial scenario set up. Now the next thing is we want to explore option B. So this is the more efficient measure per se. So here we have a total cost of, it gave us $660,309 in the worksheet. However, I may have measured, to be technically correct, because someone might notice it. I think did they want to use all the measures or just using I thought I read somewhere that they only wanted to explore using.
Yeah, the demand control.
Demand control ventilation. So, I mean, we can do both quickly. So we have $660,000 is the total, or I can subtract out the $190,000 for the heat recovery. So we can go 660,309 minus 190,320. So if we're just doing the demand control ventilation, it's $416, almost $470,000. But what I'm going to do is I'm actually going to put the higher value in first. It's more money, and see how this plays out. If you're spending a lot more money and you can reduce further and it still makes sense over the life of the project, maybe you do that as well. You find that extra $190,000 somewhere, and it maybe actually be in the savings from that demand control ventilation. So $660,000. And there is ways in some of the future tools, I'll maybe mention now in a precursor, there will be ways, what I just said, you can find the money in the savings from other projects. Once we get into some of the more webinars and training on Red Screen, if you're familiar with that, there is ways to actually explore doing that. So you can use the savings from one project to fund another project there. So stay tuned for that if you're interested in some of those tools. Now, the electricity usage after we've put these heat pumps in is 177,535. So our electricity costs have actually probably drastically gone up, and then that's still at 13 cents kilowatt hour. Our natural gas consumption has plummeted. Just have our hot water heater now, and that's at 45 cents a kilowatt hour. Our O&M costs right now, we don't have any, so we'll put 0 in for now. And then we'll just do it over a period of 1 in case we come back and we want to play with estimates on these kind of maintenance costs. And our carbon tax, we are offsetting, or not offsetting, we are paying for 15 tons of carbon here. So we can see kind of after 30 years, our present value is on the project on the first one here, it's $1.8 million. And our second project here is at $1.6 million. So after 30 years, this more expensive project by 3 or 4 times is actually cheaper. So we can see that in kind of a bit graphically on the next page. So once you've kind of put in all those numbers, you can go on to our summary of results. And it should show us some of those simple financial metrics we kind of looked at in the interactive fact sheet here. So we can see our initial costs here. We have 120,000 versus 660. Our O&M costs and carbon costs. So that first option, that's where we're getting killed on this one, is that our O&M and our carbon cost is $664,000. Now, we didn't put in an O&M cost in our option B, so we may need to explore that. It's $72,000. So it's the fact I personally would probably question that value right now and go back and play with some numbers. Even if you do the same, it's probably a good place to start here. We have our energy cost. We actually are spending a little bit less on option B here. So as the price of gas potentially goes up, this will look even better. So we have a total cost of $1,665,596 versus just over 1.6 million there for option B. So again, depending on your organization's goals, I would say this is a pretty decent project over 30 years, but it's got a net present value of 540,000, a net present value of 202,000, internal rate of return of 5.2, and a savings and investment ratio of 1.38. So all those metrics kind of meet the rules of thumb. We want a positive net present value. We want, a high internal rate of return, higher the better. A 5.2 on any investment that I have is pretty good. And we want a savings to investment ratio. We want to pay back more than we invest in. We could also reduce that and say we want to do 15 years. You can see how that works. And again, if this heat pumps were only to last 15 years, maybe this isn't the best project. So this is where we can kind of, your initial thoughts may not be what give you the right answer in the end. So we have to play with these numbers based on your goals within your organization. I'm going to leave it back on 30 years for now. And what I'm going to do is actually going to go back in there right now. And I'm just going to put in a $12,000 a year maintenance on that and see if that does change drastically the thing. So yeah, it does. So we do have to probably look into, do a bit more digging on what the operation and maintenance costs would be for 8 rooftop heat pumps there. So you probably call an HVAC contractor and they would give you some numbers on that. But again, even if this is the case, maybe it's still going to cost you a little bit more over the life of the project. But if your goals are to reduce your carbon, this may still be a viable project. So you can see how you can play with these numbers relatively quickly in order to get kind of a quick answer on the viability of projects. And it's not limited to heat pumps. This calculator can be used for any energy retrofits you do in your building. It can be used on a single project or the entire building as well. So it's not just for heat pumps. There's a couple of questions there we maybe address first. The remaining carbon of, yeah, go ahead.
I was just going to say, did you want to play around with the input for the discount rate and see if we could answer the question from Jesse?
You changed the discount rate, but it didn't change any of the numbers. So if I put in a discount rate of 2, so in mine, it did change the values there. So is anybody else running into the same issue? It didn't change any of these numbers. So it did change when I changed those. So I'm not sure. That may be an issue with Excel on your computer. If you haven't enabled the macros, it may not update some of these sheets. You may need to allow the sheet to run the formulas, basically. Okay, maybe we didn't change. That's true. I mean, if we don't change it enough, and maybe it doesn't drastically change. Can the tool perform incentive calculations? Yes and no. So you could put an incentive. What I would do here is I would just reduce, you can subtract that from the cost, or you could also put a negative number in some areas. You could put I'm trying to think where you could do it. In the O&M is sometimes where we do that, but that's going to be periodically. So I would say just if you have an incentive in there, you need to basically just subtract that from the cost up front. I know when we get into some of the other tools, there is ways to directly put in the incentive, so it is a little bit more transparent where the money is going. So in this tool, yes, but it's a bit of a workaround. In other tools that are coming out like Red Screen, I'm going to show briefly here, you can do that directly.
I think you should be able to add a comment also right on the cell where you would input the cost to indicate, if you were sharing this with somebody else, that you did account for the incentive.
Yeah, I would just add notes here. The incentive has been accounted for in this project. Or you could work out how much the incentive is going to get each year and work it into the O&M as a negative number there as well. But it's going to require a bit of thinking on your part how that works. Okay. Is there any other questions on life cycle costing or simple life cycle costing? I know there will be available soon a more detailed life cycle costing tool where you can actually dive in, work into things like the value of your equipment at the end of its life. So if you are taking something out, you may be able to salvage that and sell that for some money, which can offset the capital costs. Things like that can be worked in, and you can work in and build up kind of a basket of projects. You can build up multiple HVAC systems. You can do HVAC, you can do lighting, you can do your hot water heater, you do things like that and kind of build those all up over time, see them individually or as a group of projects. So just a little more customizations to your exact situation. So that should be available to you shortly. And again, we will have more training. I think there's some planning for some exclusively life cycle costing training in the near future. So yeah, that's good. Yeah, no, and again, if there's things that you need worked into some of these tools, we like suggestions like that. We can try to work those in as well. That is a good suggestion, working in incentives. There are as many of those available right now. So yeah, definitely we'll make a note of that and see how we can incorporate things like that in there. So now I'm just going to quickly jump back to the slides to see what we plan on doing next. So I think the next thing we're going to do is I'm actually going to quickly going to dive in and do it. I'm not going to get too much into the weeds. I know if you've come across Red Screen in the past, you can get into the weeds very quickly in there. But on the website there, I'm going to bring that up. Let me find the right. I have too many windows open here. So there is some what we call archetypes. So what we've done is we've basically built up some common buildings in RedScreen. So we've modeled the energy usage. This may not be your building, but it is if you have maybe what's in here. We have a small office, a laboratory, a fire station. I think there's a rec center. So there's a practical guy. There's a rec center archetype. So we built up some relatively simple buildings. What you can do is you can take those models, you can modify them to match your building, or you can use it as kind of a guide on how you would efficiently electrify your building, depending on what information you have. So long story short, there's 2 sections available to you in RedScreen. So there's an energy modeling section or a feasibility side of RedScreen where I can actually build up my entire building if I don't know certain pieces of information about it, or I don't know how to get that from my energy bills. I can build up the entire building if you want and pull out what my heating and cooling loads are. And then I can kind of transfer that over to another side of RedScreen, which is called they call it the power heating and cooling model. In this example, we only use power heating and cooling. So we did this a couple of years ago with a few buildings. I think, is there anybody in here that kind of attended some of those webinars, maybe used the tools that were available to you? Just raise your hand if you had come across those archetypes we used. And there's instructions on how to do this process. So basically, depending on the information you have on your building, you can either start with the feasibility model and bring it over into the power heating cooling model, or if you know a bit of information about your building, kind of I think the main goal and where this tool really shines is bringing it into that power heating and cooling model, where I can quickly drop in maybe 10 pieces of information, and then I can play around with different types of heating and cooling systems to see what would best meet my needs. And I can add prices, and then I can do a lot of different analysis on that in RedScreen. So I'm going to skip over the feasibility side for now, and I'm going to jump right into that kind of, we've got certain pieces of information on our building, and we can jump in here. And I think once you kind of understand the workflow, it's a relatively simple tool and a flexible tool to explore different heating and cooling systems in there. So we set up our system, so we just have heating and cooling. Unless if you are generating power on site, you can work that in there as well. But we keep it pretty simple here. We can bring in our electricity and our fuels. So right now we default to natural gas and electricity. If you use propane, or you want to use propane, or you want to use a biomass boiler, for example, you can bring all of that stuff in here. RedScreen is very flexible in the types of fuels it has kind of baked into it. Lots of different options here, or you can actually bring in your own one. You can define, if you know information about the fuel, you can actually bring in a custom fuel here. Then what we need to do, and this is where I say a few inputs here, we need to kind of define our floor area of our building, the fuel in the base case, the seasonal efficiency in our base case. Now this number is kind of the most important number here. So this watts per square meter, we want to you can use a guide RedScreen provides you. And again, I'm moving pretty quickly through this. If you're kind of overwhelmed, like, I don't know how this works, don't worry. There will be more training on this. I just kind of want to expose you to it. It is a very powerful tool in this pathway to net zero. So you can make an estimate based on your insulation level and your heating design temperature. Again, heating design temperature, RedScreen can give you that, or contact someone who does your HVAC work in your building. They'll likely know what the design temperature was as well. So you can make an estimate there. Then what I do is I plug that number in from the estimate, and then I use that to kind of play with that number a little bit to reconcile against my historical consumption. So in this building here, we estimated they used about 7,200 meters cubed of gas per year, minus hot water. You do need to subtract out your hot water usage unless you're switching that to heat pump as well, which is 3.4%. And then we've reckoned, so we have 7,200 meters cubed of gas is used in this building. We've also done some energy efficiency measures in this building that have reduced our energy by 45%. So that's that demand control, ventilation, air sealing, doing windows, doors, all that kind of stuff. We've taken from another side of RedScreen, pulled that in here. Now we do the same thing for our cooling load. Typically, I mean, the cooling we concentrate less on because that's already electrified. So we have our 600 meters squared. We have our coefficient of performance on our cooling side. And again, we do the same thing with our watts per square meter for the building, you do need to subtract out kind of your base load, the non-weather dependent element of your electricity consumption. Again, there is ways to do that if you're not familiar with that. In the guides that are online, it does tell you how to take a graph or take your annual consumptions and figure out what your actual cooling load is in the building. Then again, we've also done things on the electricity side, the cooling side, we've reduced our energy by 50% on that side. So now we can go to our load characteristics here, and we can see our peak. The main number we want to look at here is our system peak load. So for heating, we have 13.9 kilowatts, and cooling we have 8.1. So that our system, our energy is that's going to cost us 29.5 megawatt hours per year, or 14 megawatt hours per year on cooling. So how we want to use those numbers is what I always do is record what the loads are. So 13.9 and 8.1. Now we can go into our kind of our proposed case. This is where we can explore different options on our building. Now, again, cooling, we're not working at electrifying our cooling. It's already cool. It's already electrified. Hopefully, when we're buying maybe a packaged unit, you do get an increased in your coefficient of performance. But for this example, we kind of left it as the same. So we want a system that is going to meet our needs. So we had an 8.1 demand, our kilowatt demand, or peak demand for our cooling. So we do need to try and meet that. Rescreen tells us we have 100% met, coefficient of performance of 3.2. So we have all of our energy and all of our demand met by this system. Now, where it gets interesting is in our heating system. Now, before I get into the actual details here, if you have multiple fuels, so if you're looking at doing a hybrid system, you can click the multiple fuel buttons. You will need to know kind of the distribution or estimated distribution between those two systems. But there's another way we can kind of work in a simple hybrid system in here as well, if you don't know that information. Because kind of like, I always like to bring this back to a house. The simplest example that's kind of, you probably wouldn't bring multiple fuels and turn them on and off at a certain time. You would use your heat pump most of the time and only use your gas when it's on the coldest days. So there's a better way to do that in Rescreen here. So here, right now, by default, we put in a system that's going to meet 100% of our demand as well as 100% of our energy consumption. So where I can see that here, right now, everything's met. It's not telling me I need to change anything. So I'm meeting 100% of my capacity and 100% of my heat delivered. But the interesting thing you can do here, and I'm just going to make this up to essentially, is I'm going to cut that capacity in half. I'm going to buy a half the size heat pump, which is going to be significantly cheaper up front. And you can see this is where it gets interesting. Actually, before I do that, right now we've reduced our carbon by 95.6% with doing this. But you would think, some people may think, well, if I'm going to use gas, I'm going to drastically increase my carbon consumption. But that's not always the case. So let's just cut this system in half to 7. So now we're only meeting 50% of the demand of this building, but the heat delivered, we're still actually delivering 92.3% of the heat to that building. So now what that's telling us is that extra capacity, so that doubling of our capacity, is only needed to actually meet 7.5 or 8% of our heat to our building. So do we need to buy one? Depending on the age of our current equipment. So if you have a relatively new furnace or boiler or whatever it is, so if you've bought one in the last 5 to 10 years and you're like, well, I spent $50,000 5 years ago, why do I want to spend all this money now? Again, you may not need to. You can go into your system characteristics here. So we can now see, again, it tells us the same numbers, 50% of our capacity. We're getting 92.3% of our heat. So what we can do is we can actually just click a peak load heating system, where we could then, and ideally you would just default to your current system, but we could then, and I'm just going to add in, it said 13.9, I'm just going to put that in there just to make sure we cover off our demand there. So now we can see here, that's actually, again, like I said, it's not giving me there. So that's accounting for only 7.7% of our energy in the building. So just the way the performance curves work for these heat pumps and for furnaces, you may not, and how little time the climate actually spends at those really cold temperatures. I know, talk to people out in Winnipeg or in colder climates, like, oh, heat pumps don't work because we're at minus 25 so long. You're actually not there as much as you think. And you may be able to still reduce. So we still have a 91.7 reduction in our carbon with leaving our gas in there as well. So you can still achieve some of those 50, 80% carbon reductions while reducing your capital costs and leaving existing fully functional, highly efficient systems in there that are the natural gas. So this is where we say efficient electrification, not just electrification of your systems. That's not always the first answer. So I think that's all of the main content that I was hoping to cover off. Was there any questions in the chat still?
We did have one. Yeah, there's a question about the accuracy of that simple life cycle cost tool that we were looking at earlier, compared to a full calculation life cycle cost. So maybe I'll ask Mohammed to clarify the question a little bit.
Sure.
Mohammed, do you want to just speak up and describe to Adam what you mean by full calculation? It's possible he was curious about the difference in accuracy maybe between the two.
I wouldn't say it's necessarily a difference in accuracy. It's just different set of information sometimes. Some of the more detailed tools, you're adding in more information. The calculations are accurate based on the information we've put in. Mm-hmm. There may be more information your organization needs to make that assessment. So if you want to, like the salvage value of equipment, that's one of the ones you can bring in, and the other ones you may not worry about that, so you can just stick to the simple life cycle cost tool. But if you have equipment that has significant value, that is going to affect the calculation. So it depends on what your needs are. It affects the accuracy of that, if that kind of makes sense.
And all of the inputs in the basic sheet as well, the more accurate those are, the more accurate the results will be, like the inflation rate or your utility pricing. Doing
a little bit of digging for this information makes the information that spits out a little bit better. I'm always told garbage in, garbage out. And make sure it's realistic to your organization. Not just, if you Google a realistic discount rate, you're probably not going to get a good number for your organization. Talk to somebody in your organization that would know that number. There likely is somebody who knows it, in my experience.
Great. Well, thank you, Adam. I'll go back to the slides for a moment and talk about, what's coming up next in our series. So we do have some red screen archetype models that have already been built. So if you have a facility that you're responsible for, whether it's a fire station, a laboratory, a small office, or a recreation center, these were designed mostly for municipalities. We have those templates available, as Adam was showing on the website. We're also going to be hosting more trainings on Red Screen's Virtual Energy Analyzer and Net Zero Planner. These are two new features of the software. And the trainings will be provided throughout the rest of this year. We have here the link to Save on Energy's training and support webpage, where you can find all the resources and templates. We're going to be continuing to develop more resources and templates throughout the year, so keep checking back. And if you want any support or advice on any electrification plans that you are doing, you can just email us at trainingandsupport@iso.ca. If you use the Efficient Electrification Toolkit Help Desk as your subject line in the email, that will help us get you to the help desk a lot more quickly, because we do use this email address for a lot of activities. And we will triage those requests and address them in the order that they come in. Like Adam said, if you wanted to have a copy of the tool that has 3 options for comparison rather than just the 2, which is posted on the website, we can definitely set you up with that through that email address as well. And then we have some more webinars coming up. These are actually more like workshops, and we're going to be diving into Red Screen quite a little bit deeper, starting on April 19th with feasibility modeling. May 16th, we'll be looking at using the Net Zero Planning tool. And in June, we'll be looking at using Red Screen as a financial analysis tool. So there's a link in the slides here for our event calendar, which you can revisit and register for events as they come up. You can also sign up for our bulletin and get updates when we do add new events to the calendar, or just reminders about events that are coming up in the future. So efficient electrification is one series that we have going on, but we do have a lot of other activity happening, including existing building commissioning. We have webinars on M&V. We have webinars on efficient HVAC operations. So lots to keep an eye out for, depending on what it is that you're interested in. So I'm going to open it up to Q&A right now. If anybody wants to come off mute, turn on your camera if you like, ask a question, have a discussion.
Even if you don't have any questions, recommendations on tools your organization would find useful, that's useful to us too.
Absolutely. Yeah, thanks, Adam.
Yes, that is a good idea. I have been thinking about ways to efficiently do that and accurately.
The carbon cost is applied separately though, right? So
yeah,
it might not have as big of an impact as you might assume if you're thinking that the carbon cost is baked into that inflation rate, because it's actually calculated separately.
and just on that note, if you do dive into this in depth, there's a lot of analysis you can do in RedScreen to account for the changing prices of the specific fuels. You can actually do a full risk analysis based on a change in any number of parameters to see how the project will be viable.
Okay. Thanks, Brenda. If you have questions, feel free to reach out to our email address, and we're happy to get in touch and answer those questions.
Thank you, appreciate that. Some of our technical people are using RedScreen, and a lot of us have been trained on it. So just thank you. It's really fantastic and very powerful.
Great. Hey, Michael.
Hi, just a quick comment for Brenda. So we do offer I think 50% incentives for RedScreen training, and there are various trainings, right? So there's the basic, the advanced, and I think for those we offer about 50% in them, and then of course there's the RedScreen expert training as well, which we do provide incentives for. So if you go to the training and supports page of the Saving Energy website, you'll see what the requirements are for the incentives. I think for the most part is you working in the sector in Ontario, but you do have to take the training, and if there's an exam associated, pass the exam, and then you could apply for the incentives. It's, I think, RedScreen all the way down to his R. There you go.
Here we go.
Yes.
Yeah, and a lot of us have taken the training, and I know that we are in the process of applying for the incentive at some of the buildings, just trying to narrow that down. So you've probably dealt a lot with Brent Sellis from our group.
Oh yeah, yep, I know Brent well.
Yeah, while we have the page up, I mean, there are loads of training opportunities having to do with energy efficiency and now decarbonization or electrification topics that are incented through Save on Energy, usually 50% of the cost of the training, and Bridge customers for some courses can actually get a 75% incentive off the cost of the training. So full listing is here, saveonenergy.ca/training and support. That link is also included in the chat. That brings us to our final slide. If there's no more questions, We've got some helpful links there and a sign up for the Save on Energy quarterly business newsletter as well, which a lot of people find informational. I think we'll wrap it up maybe a few minutes early today. Thank you for joining us, everyone.